All right. So, first technical issue. I think that was on my side. Perfect way to start a Zoom event in 2022. But hi everyone. Thank you very much for joining us here to talk about the future of genomic data sharing. It's great to have you with us for what will hopefully be an insightful couple hours or so of discussion. This discussion will be guided by our incredible speakers, Heidi and Richard, here with me on the Zoom. This event is run by the Good Data Initiative in partnership with Global Shapers Cambridge Hub, where our aim is to bring together an audience to converse on a topic important to the future of personal data in the data economy. We'll wait a couple of minutes to let everyone trickle in, but while we do so, I will take a second to explain some logistical points. So we are live streaming this event on YouTube where our audience is watching, but we're super keen that does not stop us from being as interactive and collaborative as possible. So please use the chat function on the event to both ask questions of each other and pose questions to one or both of our speakers here today. We'll be collecting them as we go and we'll filter them through towards the end of the event. So without further ado, we will start to kick off. So as a brief introduction to start to our organisations, brief introduction to the event in general, we'll intro to our speakers, followed by 15 minutes from each to talk through their position. This will then be followed by 5 minutes for each to make a comment on each other's points before we open the floor for around 20 minutes of Q&A. So like I said, please do keep your questions coming through the chat. We would love to hear your thoughts to figure out on social media as well. So please tweet us under the hashtag of Good Data Assembly or find us on GDI Good Data Initiative on Twitter. I would like to start with a good quick disclaimer. Our speakers have very kindly given their time to come speak with us today, but please be aware that the views they express are solely of themselves as individuals and don't represent either of their affiliated organisations. So with that out of the way, let me get started with the welcome from our organisation and an introduction to the speakers. So to start, Good Data Initiative and Global Shapers, it's great to have you with us today. As a bit of background about who we are, GDI is an independent think tank run out of the University of Cambridge. However, we now have a reach and engagement pretty much internationally. As an illustration, our working team for this event sits from both sides of the US, the UK and Hong Kong. So I'm sure you can only imagine how difficult it is to time any of our meetings. But GDI conducts high quality research on issues related to the way our data economy impacts humans, organizations and society. The Global World Economic Forum Shapers is an initiative for young people across the globe aimed at driving dialogue, action and change. As you can see from some of the stats below, we are vast and across many hubs and countries. This particular initiative comes from the Cambridge Hub. Now, most importantly, I would love to introduce you to our expert speakers who will be guiding us through some of these thorny issues in discussion today. With me, I have Heidi. Heidi is the Chief Genomics Officer at Massachusetts General Hospital and co-director of the program in medical and population genetics at the Broad Institute. Her work is focused on discovering causes of rare disease and building resources to support the integration of genomics into medical practice. We also have with us Richard, who is a sociologist with expertise in social and ethical challenges associated with genomics and biodata. He is head of research and dialogue in Wellcome Connecting Science and deputy director of the Kavli Centre for Ethics, Science and the Public at the University of Cambridge. So we thank you both very much for taking the time for this event, and we're super excited to learn from both of your experience and expertise. Before we jump into all of that, I'm going to quickly take you through the format of the event. As well as being informative, we're also excited for this to be an opportunity to understand how events like these can encourage public discussion and thoughtful learning. So how are we going to do this? We loosely model ourselves off the Citizens Assembly, the principles of which aim to encourage debate, discussion and participation of citizens in issues affecting them in society. So in its most basic form, a Citizens Assembly is a forum for a representative sample of citizens to come together and participate in open dialogue on a given issue. Often this is one of societal scale, and will involve coming to a conclusion on a specific question, providing a set of recommendations, or prioritising a list of potential actions. Operationally, a citizens' assembly consists of two main sides: a jury or an audience, mostly a randomly selected sample of citizens who come together to deliberate, this is you in the audience on YouTube, and a number of witnesses, typically experts in the field, who will present their opinion and give evidence on the issue in question. In our case, we're grateful to have Heidi and Richard. So as a result, when you signed up for this event, you didn't just sign up for the Zoom link, we also asked you to answer a poll question. And this question basically tries to get a sense of your opinion on the topic and the extent to which you feel confident in that opinion. And what we'll do is at the end, we'll also send an additional poll with the same questions to see how your perspective has developed throughout the event. So please keep this in mind as you listen. Especially important to point out here is the wording of both questions. So firstly, net benefit. We're not asking you to come to a firm conclusion either way, rather thoughtfully weigh up the options and consider where you land on balance. And then secondly, confidence in your opinion. All too often in society, we jump to conclusions, especially on topics of high personal importance. So in the next hour or so, we ask you to try and be honest with yourself about the extent to which you feel confident in that opinion, and answer that in the poll at the end. So you've probably almost heard enough of my voice, and hopefully that's now set the scene for us to dive into our debate. This will be between our two expert speakers, Heidi and Richard. Like I said, you'll hear from each for around 15 minutes, followed by an opportunity for each to give rebuttal on either position, and then we'll open it up to Q&A. So please do write your questions in the chat as we go along. So without further ado, I'll hand over to Heidi to give us an additional personal introduction and take us through the arguments for the net benefit of sharing genomic data.
Great. Thank you very much. It's a real pleasure to be here today and a really exciting format to discuss, tricky issues and topics that the community may have different opinions on. So I was asked to really develop the statement, I believe there's net benefit to sharing genomic data, So I'm going to share with you my perspectives, and just for some context, my background, I was a clinical laboratory director of one lab for 16 years. I'm now a clinical lab director at the Broad Institute, and have been for a number of years. I also play the role as a chief genomics officer at Mass General Hospital, where I'm helping shepherd genomic medicine across the hospital. And then I run a number of rare disease research programs and clinical genomic resource building activities. And so, my perspective has been from the perspective of someone who's worked in the field of genomics for now over 30 years. So if I take this statement, I believe there's net benefit to sharing genomic data. And why do I think that? Well, I would argue 3 key points. I could make many more, but I was asked to stick to 3 key points. One is that there's no doubt that genomic knowledge can improve our health. Most variants in our genome are rare and poorly understood. And the only way we will learn whether they impact health is by individuals sharing their genomic and medical data so that we can learn from that information. So that's probably my most key tenet is why there is benefit to sharing data. And the net side of that is that the risks to sharing are mostly hypothetical. We constantly, and I have throughout the 30 years of my career, constantly put into every consent form, things that could go awry, the possible harms. And it's not to say they aren't possible. It's just, things like discrimination or stigmatization. However, if we look at history, there's actually very few examples of harm done, yet hundreds of thousands of examples of benefit from genomic data sharing. So if we look at the net benefit to risk, I would argue that there is huge net benefit compared to the risk. That said, at the end of the day, balancing the risk and benefit is an individual choice. And each person may have a different perspective about their own personal concerns over the possible risks and the way they see the possible benefits. And my third argument is that we can actually create this optimization uniquely for each individual to allow it to be customized and allow each person to make that decision. There are now systems that enable us to allow individual choice on how widely to share one's genomic data, which allows each person to optimize that risk to benefit ratio, which may be I'm not sharing anything, and that's okay. But it's really them making that decision for themselves. So those are sort of my key major arguments in thinking about this statement and this question that we're talking about today. I'm actually now going to try to back up my net benefit arguments with some real cases. You know, I tell you that this is going to improve our health, but has it really actually done that? So I'm going to, I can't control the slides. I'm going to direct the slide controlling. Can you skip to the next slide, please? So I'm going to give some examples of the fact that genomic data sharing has been going on for many decades. And here's just 3 databases I'll point out specifically. The ClinVar database. This is a database of variants that have been identified in patients. And there's been 2.5 million submissions of classified variants from genetic testing and genetic research studies from patient testing that have been shared. And that has hugely changed both the culture of data sharing in our field and the benefit to patients. Patients are now getting more consistent and more accurate interpretations of variants in their reports that they get to aid in their care. And that database has been in existence for now about 10 years. The Nomad database has over 160,000 genomes shared. It is aggregate data that is publicly accessible. You can type into your Google browser or whatever browser you use and search for Nomad and come upon the website and look up any variant in there and get the aggregate allele frequency information. And these allele frequencies have been used and aided in the diagnosis of millions of patients. Pretty much every clinical genetic testing lab, probably all of them, use Nomad data in their pipelines, and that is hugely beneficial to the interpretation of genetic and genomic data. Also, the Decipher database in the UK has over 40,000 genomic and clinical data sets. So this has both the genetic and the clinical data together that are publicly accessible. And it has been an incredibly useful database to learn about the effects of variants and what clinical manifestations they lead to. And then just as a broad bucket, there are hundreds now, probably thousands of biobanks that are collecting genomic and medical data from patient cohorts that are routinely sharing that information to inform human health and disease studies. And there have been many thousands of publications that have come out from the sharing of that information. One great example is the UK Biobank, one of the most widely used data sets for understanding genomic variation and its role in health. And that data set has been made widely available to the global community and has hugely benefited our understanding of genetics. Next slide, please. So I'm going to give some now very specific patient examples. This particular example happened to be written up by Ed Young, who's a writer for The Atlantic, and also a winner of many awards. So this was a pregnant couple that got genetic testing from the clinical lab I used to run. And they had a variant that suggested the baby may have a genetic disorder, but that variant's interpretation wasn't fully clear. And they were of a specific ancestral background, in this case, an Ashkenazi Jewish background. And we were aware, this is now many years ago, but we were aware at the time of a particular data set of genomes from Ashkenazi Jewish individuals of that ancestry, which would have been really important for interpreting this variant. I reached out and asked if I could get access to that data to interpret this variant in this couple, and I was denied access. And so they weren't ready to share that data. As a result, the couple made the decision to terminate the pregnancy based on the information that they had at the time. And then later that data set was shared and actually showed evidence that the variant was too common to actually cause disease. There were many individuals in that population that had the variant. And so it was actually a benign variant. And a very different outcome of this particular story would have happened had that information been shared. So this is actually an example of harm due to not sharing, sort of the opposite argument. Next slide, please. Now, interestingly, a very similar story happened a number of years later. In this case, there was a pregnant woman who got testing due to a very similar finding during pregnancy, an increased nuchal translucency measurement. It's like the thickness in the back of the neck of the fetus. They had a genetic testing result that showed a variant of uncertain significance. But at this stage, we now had the ClinVar database where data was being shared publicly. And the family was quite savvy. They saw that my laboratory had submitted an interpretation on that variant. Now, that interpretation was uncertain significance. There was another lab that also had submitted the same variant with uncertain significance. So we now have 3 labs. However, we were able to combine all of the data together and reclassify that variant as benign once we took all of the information together, because we're all sharing and we knew each other's data and we could aggregate it. And that pregnancy was continued and they had a healthy baby boy as a result. So a very different outcome based on genomic data sharing, different than the prior story I told you. Next slide. Some of you may have, I don't know how familiar you are with rare diseases. One disease you may have heard about in the news, because it tends to hit the news, is hypertrophic cardiomyopathy. You hear it most when a professional athlete dies of this disease. And I put a little screenshot of many professional athletes who have died due to cardiomyopathy: Reggie Lewis, Hank Gathers, many others. Although the average adult individual also dies of this disease, sadly. So it's not just professional athletes. And I'm going to show you a story of a family, because sometimes it's young children that can die of this disease. And in fact, in this, what we call pedigree down here, where you're seeing 2 parents and many children arising. Now, this actually happens to be a sperm donor who had his own 2 children, but also through sperm donation gave rise to many other children. Sadly, one of those children, the one right here, died at age 2 years old and was actually misdiagnosed with a non-genetic disorder. But it wasn't until the second child came to clinical attention. They actually fainted on a soccer field at age 9, I believe, that they were actually appropriately worked up, diagnosed with cardiomyopathy. And then the clinic reached out to the donor, and we tested the donor and identified a variant, but it had never been seen before. And so we needed information from the rest of the family and the willingness of those families to share their data, their both medical data on any symptoms of cardiomyopathy, as well as the genetic data. Those families did share that information. We were able to classify the variant as pathogenic by correlating it with disease and variant. And then we could predict risk in all of the other children that hadn't yet showed any symptoms. And so you can see this individual, so that the colored symbols mean they have some evidence of disease, actually significant, and the dark symbols, or minor in the light symbols, or nothing in the white symbols. So these individuals that have pluses means that they are at risk, and we can specifically tell you which ones are at risk and might have to have an intracardiac device put in so they prevent sudden cardiac death in those individuals, and they're monitored carefully for heart disease development. Whereas those that have the negative signs can be told they are not at risk for this very serious disease. Again, a wonderful example of how there is benefit to genomic data sharing. Next slide, please. Here's another example. This is from our Rare Genomes project. So we run a rare disease program. It's a research program, and we enroll individuals anywhere in the United States. Unfortunately, our IRB only allows us to enroll within our country, but there are programs like this in other countries. And we enroll individuals. We get agreement for them to sequence their genomes, collect all their medical information, and they consent to broad data sharing of these genomic results, not just the results, the full genomes. So the 2 children in this family, the ones shown here in the dark symbols, had microcephaly, which is an enlarged head, seizures, global developmental delay, and they were non-ambulatory. They couldn't walk. And we found 2 variants in this gene, PPIL1, one from mom and one from dad, but this gene had never been linked to disease. And we find variants in lots of genes. This isn't enough to say that these two variants are causing disease in this family. However, on the next slide, we have developed a platform called the Matchmaker Exchange, and this is built on the principle of what we call genomic matchmaking, where one individual with a rare disease who gets genetic testing and you find variants that you suspect might be causal, but you don't have enough evidence, you can, but if the same gene, that PPIL1 gene that I talked about, is also a candidate in another family, you get matched. And then you can compare the phenotypes, the clinical history. And if it's the same, it starts to build evidence that that disease is connected to this gene. So we've been running this platform called the Matchmaker Exchange to match families from around the world. There's nodes, there's now 8 different nodes around the world, and we allow this matching. And what happened with this particular case is we actually matched with 7 other families around the world who had agreed to share their data. And we brought all these families together through a collaboration with Joe Gleason, a researcher at UC San Diego, and we're able to implicate this gene and disease and give a definitive diagnosis to these families who now have the opportunity to learn from each other and potentially seek out treatments in the future. Next slide, please. So those are just a handful of examples of real live case stories of the benefits of data sharing. I could go on for the next like 10 days and tell you more and more stories. I have built them up over my years. But I do want to say that, yes, there are risks. This is, this argument is not that there are no risks to genomic data sharing. There are some, although I still would argue most are hypothetical. But I'm going to give you an actual real example where unintended, things happen with genomic data. So in this case, individuals shared their genomic data with a biomedical research program that shares aggregate data with the public. The same individual may have gotten their genome analyzed for genealogy studies like Ancestry.com, those types of services that allows posting of genomic data and surnames on the public, internet. And it is possible for someone who's more sophisticated, and in fact, Jan Ehrlich's group, to actually use those data sets to figure out that a family who's posted their data on the internet is actually present with high likelihood in this biomedical research program data set. Now, what does that mean? There may be no harm there, but there could be harm. Maybe that family doesn't want to be identified as having been in that cohort, and they agreed, that they thought that they would remain anonymous. So that's an example where, there could be some risk, and this ability to do this was actually shown and published as something that was capable. So there are some risks that you might not anticipate when you sign up for data sharing. Next slide. So as a result of learning these things, we are getting increasingly sophisticated at mitigating risks. And that enables each participant to make a choice and balance those risks. And so the things that we do to mitigate risks, we certainly educate participants, don't post your data publicly on Ancestry website if you're also sharing your data with other data sets that you want your data to remain anonymous from. We also are now making researchers sign a code of conduct that they are not allowed to try to re-identify anyone. That's routinely done. Most of the programs, instead of, when someone asks to get access to data sets, you just let them download and put it on a laptop and carry it around. We no longer do that. You have to go to a secure platform to look at that data instead of letting it be downloaded. So that's another way that we can better control the security of the data and the potential risks. And then most importantly is about allowing individuals to have many choices for how and with whom they share their genomic data, so that, again, as I mentioned before, they are enabled to make these decisions around the net benefit themselves. And I will stop there and happy to turn it over to my colleague for his comments. Thank you very much.
Wonderful. Thank you so much, Heidi, for a very compelling talk, both in kind of the hard statistics, but also the real life personal stories of how the sharing of genomic data can be beneficial. with that, we will move on to our second speaker. Grateful to have you with us as well, Richard, to talk us through the arguments for some of the net detriment of genomic data sharing.
Thanks very much, Francis, and yeah, thank you, Heidi. I think yeah, I noticed the typo on the previous slide, and I think after Heidi's talk, it might be easier for me to talk about the detriment associated with micro targeting than associated with genomic data sharing. And I think, because I do want to. So as I mentioned, I'm a sociologist, and I've worked for quite a while now on those questions associated with how we kind of make data available about ourselves, how we govern those kinds of how we govern those data, what our concerns are, and particularly kind of questions around who we trust with that data, why we trust them, what we might do to build more trustworthy data systems. And I do want to, so I want to start off because I think that genomics is a really interesting area to focus on for this, in part because whilst the whole world is now doing big data in one form or another, genomics as a field has been kind of dealing with these questions for longer than many, and has also pioneered approaches to open science and the kind of sharing of data to maximize scientific benefit, I think, in ways that other fields can learn from. But in thinking about this question of, I believe there's a net detriment to sharing genomic data. I started thinking about, so what are, in order to realize some of those benefits that Heidi talked about, which are these kind of emerging real clinical benefits, how do we ensure that those benefits aren't outweighed by some of the harms that we might generate? And that whilst some of those harms might be hypothetical, they might also be less tangible as well in terms of people's kind of expectations and feelings about what's known about them, who and by whom. So I wanted to start with three conditions essentially that I felt are necessary to be fulfilled, and without which you could argue that there is a net detriment to sharing genomic data. And so the first one I think really picks up where Heidi left off around this question of privacy and the privacy of data related to individuals, and particularly in the case of genomic data for their families as well, or those who are related to them in some way, and the need to protect that data. So, and then the second condition is about how we use the data and for what purposes. And so I would argue that it's difficult to realize the full benefits of sharing genomic data unless those benefits are aligned with the values of the individuals, the families, and the populations who donate data or who are represented in those data sets. And then closely related to that, I think, was a third condition about how we ensure that. And that I think it's important that we ensure that decision-making about data sharing and the use of genomic data is transparent, and that we can understand what data is going where and how it's being used by whom. And again, that it aligns with the value of all stakeholders, and that we have mechanisms for including the voice of those stakeholders where appropriate in decision-making. Okay, so yeah, I mean, like Heidi, I'm going to go through those one by one, and talk about some of the particular concerns we might think about associated with the sharing of genomic data. So next slide, please, Francis. Thank you. Okay, so this is the long COVID table of Emmanuel Macron and Vladimir Putin, which I want to use to talk about privacy. And so this question of privacy is a general question for all forms of data that we generate or that is generated about us. And it's about the ability to control information about yourself and to determine with whom it's shared. And I want to flag up here that as I talk through this, I think it's important to recognize that these questions might be slightly different in the case of genetics and genomics than they are in other domains. But the first questions, the first set of questions really are about whose data is held, how did it get there, and what does that mean when it's there? And I think that the example that Heidi gave of the individual who's in a research data set and then shares their genetic data through a genealogy website, for example, is a case in which, even when we choose to generate this data about us and we choose to share it, how that might be used and what its effects in the real world might be can be unpredictable. And you've seen that over time as people have made genetic data about themselves available. So, for example, some of the early individuals who had their whole genome sequenced and chose to make those sequences unavailable attempted to redact certain sections of that data, for example, related to their Alzheimer's disease risk, only to be for it to be shown that you can impute some parts of the genome. You can impute the missing parts of the genome by analysis of neighboring sections. And so that it's difficult for us to know what information we're making available about ourselves when we do share. And that's in the situations in which we have control. The reason for putting up the Putin-Macron table is that there are also concerns, possibly apocryphal in this case, but it makes an interesting image anyway, but about whether and when our genomes may be sampled and tested without our knowledge. So one story around this meeting was that Macron refused to have a COVID PCR test because he was concerned about the Russian state holding his genetic data as a result. There are other, again, possibly apocryphal stories about concerns about celebrities and their obsessive behaviors about ensuring that genetic samples aren't surreptitiously tested. But it does present a concern that even for some individuals, there is the ability for genetic information and for your genetic privacy to be breached, possibly without your knowledge. But there are also larger concerns related to this and to the large-scale privacy implications of genetic data collection and its use. So particularly where that involves the state, where data is taken from potentially vulnerable populations and may be taken without consent and in ways that underpin wider discrimination, stigma, or potentially even persecution. And there have been concrete cases in recent years of scientific journals withdrawing data taken from Uyghur populations in China and highlighting and flagging concerns about data held on Roma populations in Europe, and concerns about the use and the collection and holding of DNA data by immigration services, particularly in both the US and the UK. And then there are, I suppose, more subtle concerns in that because of the shared nature of genomic information, there is the question of whose privacy are we talking about? And this is perhaps more relevant in this context than in some other data context. And that's kind of central to some of the potential of genetic information, to some of the large-scale data sharing initiatives that Heidi described, and also for the use of things like GEDmatch and other genealogical websites by law enforcement that makes it possible for family members to track down distant relatives, but also for the police and law enforcement to track down family members of people with whom they share elements of their genome. And if you just go to the next slide, please. Thank you. Yeah. So the choice of an individual to make their data available within these genealogical websites or through direct-to-consumer genetic testing then has implications not only for themselves in terms of the unpredictability of what's going to happen with that data, but for others. So this is a 2018 paper in Science that estimated that the existing genetic data held in a consumer genetic database would be sufficient to identify around 60% of European ancestry individuals in the USA. And that's heavily skewed because of who's in those data sets. But whilst research and consumer testing data sets are heavily overpopulated by people of white Northern European ancestry, racial biases in the criminal justice system and immigration systems are reflected then in forensic DNA databases, in which people from Black and other minoritized populations are 2 to 3 times more likely to be represented. And that has implications, again, for individuals who were never themselves tested for these data sets, but are related to those who are. So as we share data, this question about about the implications for the privacy, not only of the people whose data we hold, but for their relatives becomes really, really important. And protecting privacy in this context comes with these kind of difficult technical challenges. The example again from Jan Ehrlich's group that Heidi showed, that however we have, as we have attempted to de-identify and anonymize DNA data sets, it's been repeatedly shown as well, the fact it's been repeatedly shown that these can be re-identified if somebody has the technical skills, resources and time to do so. So we have this kind of technical arms race about to the extent to which you can effectively anonymize genetic data. But it also means that we need to think about the social, the ethical and the legal frameworks that we have put in place to ensure that privacy is protected wherever it can be, and how we act as researchers, as companies, as members of the public to ensure that this privacy, is protected. Okay, so next slide, please. Okay, so the second condition that, the second concern related to the conditions that I put up before is that there's a risk that benefits that accrue from the sharing of data don't necessarily return to those represented in data sets. And that might be either because the value is entirely privately captured, so as is the case in some consumer genetics contexts, or because the value associated, the value that's generated from sharing of data might happen in a different geographical location from the population from whom it was, from whom the data was taken. So one thing that we know from when we've gone out and asked people, why do you take part in genomics research? Why do you donate samples and information about yourselves? Is that people do it out of an altruistic desire to help others, or a solidaristic view that that any of the individual risks that you bear are outweighed are outweighed by the wider societal benefit that comes from the use of these data. And this speaks to that kind of social value that Heidi described and worked towards. So because of the importance of, because of the kind of the rooting of genomics in those altruistic and solidaristic motivations, there is a need to ensure that where benefits are realized from data sharing, that they are available to the greatest extent possible. And in particular, we need to ensure that where there is significant public sector investment in genomics, in the UK, for example, through Genomics England or Our Future Health or UK Biobank, that these projects contribute to benefits that align with these motivations and that contribute to some idea of the public good. And the importance of this is reflected in this graph here, which comes from work that we did over the last few years of an international survey of around 40,000 people, looking at people's attitudes towards the sharing of DNA and health information. And so this graph shows people's willingness to share their DNA data with different institutions or actors within the kind of health data ecosystem, and particularly concerns that data collection and sharing focused on what might be seen as the pursuit of profit and private benefit is less motivating than those focused on public benefit. And that then, if you go to the next slide, thanks, that this is reflected in questions about who we trust with our genomic data. And so so here you can see that people were highly willing and highly trusting, of their own doctor, of sharing, giving their genomic data as part of a clinical workup, for example. But as soon as data moved out of that context, people were much less likely to say that they trusted anyone else, particularly companies. And then what I haven't shown here, but what we also looked at, was that when you look at the sharing of data outside your own country, all of these levels of trust drop off even more substantially. And this is important because we do need to ensure that as data are shared internationally, and particularly from low resource to high resource settings, that the benefits associated with this are also shared. And that we need to be clear about what those benefits are. So if you go to the next slide, please. Okay, so this speaks to my last point about the need to avoid decisions about genomic data sharing that are opaque and that are difficult to explain or justify to the people about whom data is held, or decisions that are unexpected. So the UK's Information Commissioner's Office and the UK NHS, in their discussions of how health data should be used, adhere to what they call a kind of no surprises model, that patients should know how their data is used and for what purposes it's being shared. And this really gets to the nature and the transparency of the decision-making process under which data sharing occurs. So in our work, for example, in that survey work, we asked people about what kinds of things are most important to them in terms of who they trust and how they trust and why they trust people with their genomic data. And this question about who's going to benefit, who's going to be using data, for what purpose, and how are others going to benefit are really central questions that we need to be able to answer in order to ensure the sustainability of genomic data sharing, and to ensure that the benefits that come from it are those that are aligned with the values of the people that we ask to give their data. So in terms of kind of clarity about how decisions are made, large-scale genomic data initiatives often have data access committees that make decisions about data sharing. And there's a need to make sure that those bodies, which are often highly expert and highly functioning, but we need to make sure that how those bodies work is transparent, and to know that there are standards of how they should operate, and to consider perhaps whether, when, and how those about whom data is held should also be represented in this decision-making process. And this is a question that has come up more widely in questions around data about the nature of representation in decision-making. So in conclusion, then, I think, to avoid genetic data sharing being detrimental to some individuals or populations, and to ensure that it sustains public trust, it's essential that we address all of these kind of wider ethical and governance and legal challenges associated with its use. And I would say in closing that the genomics community as a whole, through initiatives, some of which both Heidi and I are involved in, like the Global Alliance for Genomics and Health, have really been working towards this. And I think that it is fair to conclude that whilst some of these risks and concerns persist, genomics, I think, is ahead of many data-intensive fields, and particularly outside of medicine as well, in addressing some of these challenges, but does need to keep pushing forward. So thank you very much.
Wonderful. Thank you so much, Richard, and super insightful and nuanced, and very interesting to understand, more about the technical arms race and ensuring anonymity, as well as kind of how do you balance the benefits and ensure trust, which is super important for the future of the field as well. Wonderful. Thank you so much. So like I said, now we will head to kind of 5 minutes opportunity for either speaker to sort of give comment back on the other from what they've heard in the past half an hour or so. And I think I'll start by going to Heidi to make any responses to what Richard said.
Sure, thanks so much. I mean, at the end of the day, I actually don't think Richard and I are really coming from different perspectives, in the sense that my argument was that in most cases, the net benefit is there in terms of the benefit over the risk. However, that is an individual decision. And I think he gave great examples of occasions where that net benefit is not the case. And that may be because of who's controlling the data sharing, who's collecting the data, how transparent they are, what their method of sharing is, who they're sharing with, all of those things. And for a given study, one could argue the net benefit is not benefit over risk, and the risks are actually higher in certain studies or certain programs or certain countries, or depends on the situation. And also it's an individual decision, because an individual may have more to lose than another individual because of their background, the potential for stigmatization and discrimination and things like that. And so, that decision is sometimes an individual decision, and it's obviously going to be dependent on the context of what is the study and what have they shared, do you trust them, etc. And so I think, in a lot of ways, I don't see a fundamental difference of agreement from where we sit. It's just a matter of, really the transparency, the understanding, and allowing the individual to make their own decision. So I'll stop there and turn it back to Richard.
Yeah, no, I mean, I would agree. I think, yeah, I mean, it's interesting and yeah, and encouraging to see the actual benefits of data sharing accruing. And I think that's and I think that there's always that there has been a kind of a narrative at times, and I think, I mean, certainly in the past, it's been something that's been part of talks that I've given around ethics of genetics, is that 10, 15 years after the Human Genome Project, where were the benefits that were the big story, the Bill Clinton and Tony Blair standing up there talking about, this is going to change everything. And I think inevitably that process of moving into the clinic is a slow process, because clinical innovation is a much slower process than technical innovation at times, with good reason. And so, yeah, so I think that's great. And I think that what we are seeing is the emergence of really robust frameworks around the collection, control, and sharing of genomic data, and particularly the ability to introduce technical controls. I mean, in the UK, for example, you've seen the development of a lot of trusted research environments or secure research environments, these contexts in which you're no longer sharing data. You're allowing people to come to the data, but you're not allowing the data to go out. Right. And that has changed, I think, some of the discussion over the last few years. I think what the challenge is, and I think this is where it speaks to the work of the Global Alliance for Genomics and Health and similar groups, is to take that learning and those frameworks and things, and to develop them at international scale, and to make sure, because essentially, I mean, the whole of genomics as an endeavor is vulnerable to the bad actor effect, and that and so I think that was so some of those things I talked about as detriments, I mean, they are things that I mean, they're no surprise to, I think, anybody who works in the field. They're just the things that need need constant attention, essentially.
Yeah. Agreed.
Absolutely. Well, with that, we can maybe head to questions, and segues quite well actually into my first question, Richard, on bad actors and their ability to do things that weren't initially intended by people giving permission. So one of the questions we had coming through was, is it possible to ensure that permissions an individual gives when they first sign off on their data is respected? And I guess you could answer this in its yes or no form, or perhaps give examples of times that you've seen this been investigated particularly well, or looked into particularly well. But yeah, basically around the question that when we say what we want something to be used for, is it possible, or how do we ensure that it is used for that in the end? Maybe
so,
yeah.
so yes, no, I think that I suppose there are two ways. So that, so if you'd asked me, yeah, I suppose 10 years ago, I think you are reliant on actually what, ironically, I think what, and we've recently written about this, what you used to have was essentially a trust-based research environment, in which if somebody wanted to access the data, there were a set of agreements and and kind of commitments that they would have to sign up to in order to use that data. So, for example, not attempting to identify it, not sharing it onwards, and that within that, like, yes, you probably could enforce at times, but it was quite fuzzy, and it is a lot more trust-based. Ironically, we've now moved to these things called trusted research environments, which actually don't require us to trust at all, because the researcher can't take the data out. So we can put in place controls that ensure that the data can't be used out with the kind of the consent parameters. So within those kind of contexts, you can technically control it. Otherwise, you are reliant upon much more kind of social processes and norms and where possible legal frameworks to ensure that you don't, that re-identification, for example, doesn't take place.
That's right.
Anything to add on that, Heidi?
Sorry, say that again.
Anything to add on that?
No, I mean, I do think Richard is correct in the sense that, changing the environment to you can come to the data as opposed to sending the data to you does eliminate some of those risks. At the same time, the group that has that data is still in charge of doing stuff with it, even if it's on their premises, right? And so it's still important to be transparent with what are the goals of the project, how will this data be shared, who will use it, for what purposes, what information, will become transparent. And, I think also moving towards a framework where we can bring benefit to individuals for participation that is more direct. So for example, most genomic studies used to be share your data because great things will come from it for society. We'll learn stuff, it'll be useful in clinical care someday. But nowadays, we can actually directly give back to the individuals who share their data. Sometimes nothing, but sometimes something very tangible. And the examples I gave in rare disease, it's actually very common that we can give something back. We can often figure out what the cause of their rare disease is, and we return those directly to those individuals, their families, and they can, in their own lifetime, directly use that information. There are other studies where it's a little less clear what we can give back. But for example, in the All of Us research program in the US, we agreed to give back those individuals any actionable information from their genomes as essentially of value to them. It wasn't that we were needing to look at that information for our studies. We were simply interpreting it and giving it back as a return of value, to say, gee, we know you spend your time and your risk, giving this data, sending us your clinical information, all of that information. Is there something we can give back to give benefit back? And so we are now giving actionable results to those individuals. We have platforms that allow them to compare themselves to others and even get better access to their own medical records, which are sometimes difficult to get access to, but we've collected those and the ability to actually share them back with the individual whose data it is. So I think there's a lot of ways to think about further benefits than our traditional, as well as needing continued transparency over the groups that are doing the research and what exactly they're doing with it.
Interesting, thank you. Next question we have is, sort of around how much independence should individuals be given to share their genomic data, given many people maybe don't necessarily understand what they're consenting to when they perhaps share. Would be curious to hear any thoughts on this. Yeah, perhaps Heidi, lots of nodding, so maybe we'll go to you first.
Yes, it's a great question. And, while it's great to say we're going to, give individuals full access to tell us who, with whom, and what, and for what purposes. But I can tell you, even though we have better ability to manage some of that, it is still very hard because we share data in batches and, allow systems to then allow that data to be accessed for other studies. We use coding and consent codes to, indicate which data can go where. And it is actually harder to individualize, like, well, this data set can be shared with a researcher studying diabetes, but not hearing loss. We actually don't have a consent code that lets that delineation. So there is some limitations, and the more complexity you add into that layer, the more resources required, and the resources are at every level. At the consent level, to be able to even explain, what the options are, and try to delineate the details of different risks and different choices. Then there's the systems that have to manage that. And my team uses the UK Biobank data, and we occasionally get emails. This person has now withdrawn their data. You need to go into your system and pull, stop using that file and pull this data out. It's actually quite resource intensive for us to try to, change that when the individuals change their mind. So I do think there are downsides, and the more we can sort of group categories of things and make this as simple as possible. And there's plenty of people who would prefer to just have a trusted individual give them guidance. And we often work with trusted, representatives in many of these studies and recruitment arenas. So for instance, when recruiting individuals of Native American populations, it's much better to work with a tribal member who really is trusted by that community. We can work with that one person, but they can really be a shepherd of that information to their community, because that community trusts that individual to make those decisions. Then they may not want to invest the time and energy to figure out every detail. And so I think there's a lot of ways that we can think about return of value and also making this easier and not excessively complicated.
And Richard, anything to add?
So yeah, a couple of things, I suppose. One is, the question around, once data about you is kind of held, like, how do you withdraw it? I think is because, in that survey work that we showed, the ability to take your data out, even if hypothetical, is kind of quite important to then trusting the system. But actually, once you put that into practice, it becomes hugely resource intensive for everybody, and in some situations just may not be possible because things will already be published, and the data will have been used or transformed in various ways, and so you can't. The ability to guarantee that you can always take every instance of that data out from wherever it is, I think is not least because it relies on the researcher who's using UK Biobank data actually doing it. And if that, so I think a kind of, the kind of clarity about, actually what does that mean? So, like, yes, the principle is really important. The practice is really difficult. And then in terms of the kind of broader question, I think about, people like what, so if I take part in a study and I put in a subject access request under the GDPR, and I get a USB key with my kind of BAM file or VCF or whatever, like I get the kind of actual data. Like, what do I do with that, and how much metadata about what types of kit was used in generating that data do I need in order to be able to take that to somebody else and say, look, this might be really useful to you. Like, this is, so because there have been ideas around kind of personal individual genomic data banks and data stores where you can have your data and you can share it with the projects and things. But one of the difficulties is actually knowing kind of things about the provenance of that data and what's in it when you take it to somebody who's going to do something with it. And then, as well as the fact that if you take the kind of population of people who are likely to do that, they're possibly also not the kind of representative type populations that you might want to have within your study. So I think there's so having the data on your USB key, brilliant, but actually ability to do anything with it, again, possibly more complicated. And then I think that the final thing is that question about family members, that your genomic data isn't just your genomic data. It's your siblings, it's your parents, it's your children's, and never mind your kind of cousins and things. So actually, if I publish my genome online, what kind of conversation do I need to have with my sister, for example, about that, or with my parents? If I put my genome online and it happens to show that I'm an ApoE4 homozygote, that I'm at highly increased risk of Alzheimer's disease, it means that both of my parents carry that E4 risk allele, and that therefore I've got to then go and tell them something about them. I mean, I may know that already, but I need to be aware that that's potentially going to be a conversation that I'm going to have.
Not an easy question at all. And sorry if my audio has gone strange. I'll try and speak as clearly as possible, but I'm having people tell me it's a little bit strange. A couple more questions have been coming through. One for you, I think, specifically, Richard, to start, on how do we ensure the benefits of genomic data being shared do extend past kind of the global north, essentially? Like, how do we make sure that when people give their genomic data, it goes to the right places, whatever that may be? Have you had any interesting research in this area, or have any thoughts on how we can make sure that happens?
And I suppose the question about how do you know it's going where you're expecting it to be does come down to an extent to the kind of governance and the chains of control through the process, and the fact that that's done properly, for want of a better word. The questions about the kind of the equitable distribution of benefits of genomics, I think, is a huge question at the moment, because there is a well-recognized issue now that the genomic data sets that are used widely are not representative of the global populations, and that therefore some of the analyses that you produce from them are not necessarily equally applicable. And so there's then there are a series of initiatives to try and expand the representativeness of global genomic data sets. And I think that the issue, I think, really is ensuring that not only the kind of benefits downstream in the future, kind of 15-20 years loop back, but also the questions around capacity building, about building local expertise and research capacity, is part of the picture now. As a kind of broader question. But that's,
and Heidi, any additional comments?
Sure. I mean, one of the realities is that each population's data, particularly in how we use it in rare disease, is actually highly relevant for another population. So we use data from African American individuals who may have high allele frequencies of certain variants that can rule them out as causal for any population. The same true of European ancestry individuals may have high allele frequencies of other variants that aren't found or found at lower frequency, and we're using that information from one population to help interpret the other. So there's a lot of reciprocity, I guess, in terms of how we use that information. But it is true that you need data from all populations in order for everyone to benefit. And so it is really important that when we do our recruitment of individuals into studies, that we are tapping into every population to allow every population to benefit. And that might require extra resources to go the extra mile to reach out to populations who have been traditionally underrepresented in biomedical research, may not have the same trust that other individuals, and we have to work harder to establish that trust, and to, cater to the questions and concerns of those populations. So we can't just say, well, I let everyone apply and that they didn't. Well, that's not good enough. We have to really think about the issues from the perspective of every individual and every population in every country, and recognize that we may have to tackle issues differently in different populations if we are to allow everyone to benefit.
Certainly not an easy task. The final question we have, I think I'll direct at you first, Heidi, is around a code of conduct, which I know you spoke about in part of your presentation. So the question is, what would a code of conduct look like? So who is kind of needed to put this together? What are the types of things you see in a code of conduct to do with genomic data sharing?
Yeah, it's a great question. I mean, the very simple and obvious one is that you must not ever try to identify an individual. And so that's just a simple, straightforward one, and one that is already in fairly wide use. But I think there's some more subtle things that also should be thought about and added. For example, I would argue, this is one you might not typically think about, that if you are doing a study where there's an obvious value to return to the individuals donating their DNA, that you have an obligation to return that value. So, for instance, I would argue that most studies doing rare disease diagnosis studies, like discovering the causes of rare disease, it is very clear to any of the individuals in this field that we can return benefit directly to those families. So there shouldn't be a study approved without a plan and the resources necessary to be able to return results to families with rare disease. And so, wouldn't be something you'd naturally think about as a code of conduct, but I think there are things like that where we have to think not just how do we reduce harm, but in fact, how do individuals benefit? And that is actually a key tenet of the Global Alliance for Genomics and Health. It's less about, we all have to figure out how to secure this data so well that no risk will ever come. Well, maybe we should reframe that and say, we have to figure out how every individual on the planet can participate and benefit from genomic science. And that's a very different sort of framing of the opportunity than to say, we will do everything possible to protect your data and make sure it doesn't fall into the bad hands. Like, the moment you hear that, you're like concerned about the risk, when in fact, there's so much benefit to come. Let's focus equally, if not more, on the benefit to come. And so I think when we think about code of conduct, it's both saying what you shouldn't do with data, and whether it's identification, whether it's, defining consent codes and making sure that sharing of data adheres to those consent elements. But it's also defining how benefits should be offered to individuals who are participating as an equal important code of conduct.
And Richard, anything to add?
It feels difficult to add anything to that. It was, but I think there is a kind of a follow-on from it, which I think is and I think is there in, say, in the US and the way the NIH approaches data, that actually part of that code of conduct is not sitting on data and not kind of so if you talk to people who run kind of longitudinal cohort studies and stuff, particularly kind of a few years ago anyway, that there's always the kind of thing, well, I need this data now because I've got to get my PhD students through, and I've spent years collecting this data, and this is really kind of dear to me, and this is like and I will share it when I've finished with it, has been the kind of has been the position that some have taken. And I think that there is that, if the benefit of genomics relies on the sharing of data, though there needs to be part of that code of conduct needs to be a kind of like, okay, you need to do, you need to have done what you need to do in order to protect against the harms, but you actually do need to then make it available.
What a great way to end, what a great statement to end us on. Thank you so much, both Heidi and Richard. Incredible comments throughout, and I think I speak for everyone when I say that we've learned a whole lot throughout this experience. So just to flag, we come to the conclusion of the event itself, but this is not quite the end. As we mentioned, we're keen to understand how opinions might have changed throughout the event, and there's a link in the YouTube chat that will ask you to give your opinion again, to vote on the initial poll that we gave you. It's just 20 seconds or so, so we can kind of understand how successful an event like this is in ensuring good public dialogue. We'll be synthesizing the arguments of the event and the progression of people's opinions. So please watch this space. This will be coming to you by email. You'll also find it on the Good Data Initiative website as well. So with that, I'd like to round up by saying a massive thank you, get everyone off my echo as soon as possible, to our wonderful speakers, Heidi and Richard. I'm sure everyone would agree, an incredibly insightful session. So many thanks for your time and your expertise. And with that, I will close the session, and we also have a feedback form, so please let us know what we did and didn't do so well. Thank you very much.
Thank you very much for having us.
Yes, thanks for having us. Take care.
Awesome. Thank you.